Okay, so today we the Group 3 are going to explain about the turbo code involving the BDP assignment, which is broadly defined project for the digital communication.
Okay, for team members, the first one is me, for Shahira binti Zainusham. The second one, Edric Bugin Anak Awang. Next, Ilman Faris bin Saiful Rizal. Next, Tiva Harian. And the last one is Karuna Nanta.
Okay, for the table of content that we are going to present in this video is the first one is the introduction, the second one is the background and theory, the third one is application and real world use, the fourth one is the advantage and the limitations, the fifth one is the chosen aspect of the improvement factor, and the sixth one and the last one is the conclusion.
Okay, first of all, for introduction, basically turbo codes are widely recognized for their exceptional abilities in mistake correction. It is have discovered something fresh in the field of privacy and security, and dependable and successful error correction techniques are in high demand in the constantly evolving field of technology for communication and information. Okay, it is a revolutionary approach that is pushing the envelope on error correction performance in a group called forward corrected error codes known as turbo codes. Okay, we move on to the background and theory. Okay, the first one, multiple convolutional coders and interleaver are used in the creation of the turbo codes. Okay, so it has four configurations, which are parallel, multiple parallel, serial, and hybrid. Okay, for the methodology, the output of the posteriori probability, which is APP decoder. So the PCC decoder does not utilize this output, but SCC does utilize the output. Okay, so in relation towards the improved probability ratios of the encrypted symbols. So many in parallel, the layouts of the convolutional coders vary in hybrid system, and by dissecting how the iterative decoding procedure helps to protect sensitive information from listeners while simultaneously fixing faults caused by noisy channels.
Okay, so I'm going to explain about the field of the application of the turbo code and the real world use. There are four applications in the real world use that we have been stated, which is wireless communication, wireline transmission, 64 QAM of OFDM for 4G, and the use of turbo code in the tactical communication. Okay, so for the wireless communication, we can divide it into two, which is for the first one is the iterative demodulation and the decoding, and the second one is the turbo receiver technique for coded MIMO or FDM. This method is more effective than the other method that I will not list here, and it will take the advantage of the various receive power level and can demonstrate that it can reach the multiple access channel capacity when used sensibly. This show us that the turbo code application for the wireless communication is a very useful application. So the second application is the wireline transmission. It is focused on the turbo and the turbo-like code design in ADSL modems. This application has two design, which is turbo encoded design for ADSL modems and turbo decode design for ADSL modems. For the advantage of this application of the turbo code in the wireline transmission is two, which is the first one is the improved error correction, which is the turbo code offer highly efficient error correction of the capabilities that will allow us to enhance the data integrity and wireline transmission. Data integrity is very important in wireline transmission. Due to this, it will result in a better signal quality and reduce the error rates. It will cause the communication to be more smooth. And the second one is the bandwidth efficiency. TurboCode provide excellent bandwidth efficiency, enabling higher data rates to be achieved over wireline communication channels. This is especially beneficial for high-speed data transmission. We can see this in the high-speed transmission that have been used by a lot of company such as Telcom, and the application of TurboCode is very crucial in this application. The third one is the 64 QAM of OFDM for 4G. It can access the bitrate error rate (BER) performance for digital video transmission utilizing turbocode OFDM and focusing on the alternating energy economy is very noisy channel situation. We can make it show this as the turbo cut can be used in a lot of noisy and opaque area, and the lower cut rates perform better at particular EB over NO value. According to the study analysis of the effect of various cut rate of at the various bit error rates, they show us that turbo cut is very efficient for this application and the research paper. In general, the turbocode has proved to be useful in enhancing the performance. The paper also described how to analyze the data using MATLAB. And for us students, we have been using MATLAB, and it can be applied to use the turbocode in the MATLAB. And as we can know, after we using the MATLAB, we can use the Simulink architecture for various code rate such as 64 QAM and turbo code or FDM. The last application is the technical communication. In this research paper, the author has proposed a multifunctional system comprising a turbo decoder, a low complexity turbo equalizer, and turbo synchronized to compensate for frequency selective channel refading. This is the summary of the whole research paper that has been produced for the technical communication for the turbo code. Okay. Uh, the next one is it present a comprehensive overview of the design, component, and simulation result of the multifunctional turbo-based receiver for tactical communication with a focus on combat radio and radio relay system.
Greetings, my name is Divaran Selvam and my metric ID is CN220429. So today we're going to be talking about one of the aspects of turbo code which can be improved, and we're going to be focusing on the privacy and security aspect especially. So mainly we're going to be focusing on that, and we're going to begin with the ways that the privacy and security of turbo code can actually be improved. So the first will be focusing on the integration of turbo codes with encryption. As we know, most messages, all messages, especially like WhatsApp messages, are all encrypted, where a third party or an outside party cannot actually decrypt and read your messages. And this is a disclaimer that you can also see in a WhatsApp chat box and all. So, unlike Telegram, WhatsApp is more encrypted. So, in that way, what we're trying to say is that when it comes to turbo code, when we integrate it with encryption, which can be replaced by these robust, which is old encryption algorithms that turbo codes actually offers, since turbo code has been there for a long time, we can actually protect the confidentiality of transmitted data and make sure there are no any unauthorized access or hacking, as we call it. So this makes the line much more secure and the messages sent over is much more secure. So next we have is confidentiality in transmission. So we know that the whole point of the whole point of us combining turbo codes with also encryption actually addresses the main fundamental challenge of where we can actually send a message through a line which is actually has an impenetrable barrier, so that it can be actually intercepted by other parties and all. So that what it actually offers basically. When it comes to turbo codes, we can actually increase much more the confidentiality of transmission of messages. And the third one will be focusing securing the initialization and termination procedures. So basically, encryption is of a message. When we send a message, the reason why it's encrypted is because it secures critical phases like these two procedures which are mentioned, which is the initialization and termination procedures, which actually it provides heightened security or advanced security to prevent any unauthorized interference. So if we equip turbo codes with this kind of inscription, we can actually say that we have a secure foundation for the entire communication lifecycle. So the entire communication of the initiation of the message, the termination of the message, the arrival of the message, and when we send a message, all of it's encrypted, and the whole cycle, there is no any loopholes for hackers and outside parties to actually eavesdrop into the messages. And then we have the next aspect is the privacy preserving technique. So what we believe is by incorporating an advanced privacy preserving technique such as homomorphic encryption and differential privacy. So homomorphic encryption basically means what is without it's basically performing complex mathematical operation on a message or processing a message without decrypting it. That is what homomorphic encryption means. Basically, you send out a message where you do not have any you do not have to decrypt it in any way. So that in that case the message is securely encrypted, but at the same time it has whatever processes or whatever mathematical operations has to be done with the message is done. So this kind of technique add an even extra layer of protection during data processing. So ensuring that any sensitive information, your ATM pin number, ATM pin code, ATM pin number, your bank details, all this sensitive information is actually shielded from unauthorized scrutiny. And then the next is the privacy enhancement in data processing. So privacy preserving techniques, basically what it means is just like homomorphic encryption and differential privacy, these techniques actually they play a crucial role in protecting individual privacy during data processing. So individual privacy could actually mean your sensitive information when it comes to your own personal details. So these kind of techniques, which is privacy preserving techniques, they actually ensure that during the error correction processes, sensitive information such as your contact details, your addresses, your email passwords, and all of that is shielded from unauthorized access. So basically, the whole privacy aspect is secured, and you're much more secure when it comes to your personal details. And next, we'll be looking at the real world applications. So when it comes to real world implications, the integration of turbo codes with encryption or privacy preserving techniques, so it actually extends beyond the theoretical application. So real world implication basically includes enhanced data protection in sensitive domains such as healthcare, finance, and government communications. For example, in hospital system, a hospital software system, a bank system, all these actually where user confidentiality issue is non-negotiable. It cannot be accessed by the outside world, and the integration of these turbo codes is all the encryption and privacy preserving techniques basically is very crucial actually. And then we'll be moving on to the comprehensive data protection. So turbo codes, when we fortify it, we strengthen it with encryption. It assures that during data transmission, there's a confidentiality, while privacy preserving techniques actually shields the individual privacy during data processing. This comprehensive data protection, what it does is it aligns turbo codes with contemporary security standards. That means the basic security standards, and position all the turbo codes as these indispensable components in secure communication system. Basically, a very outright data protection. And the last one is the adaptability and enhanced security features. So as we know that technology is going to be advancing continuously and all, so when it comes to turbo codes, one of the things we could do is we have to make sure that it's adaptable to the technology that is evolving all the time. So to remain it as technology advances, we have to make sure turbo codes with the adaptability and also the enhanced security features as has been evolving, it remains at the forefront in ensuring that the integrity, privacy, and the security of the transmitted information. And this adaptability, which is why turbo codes have been implemented for a long time, and it's suitable because even though the communication system is evolving, turbo codes is able to adapt to it. So that is all from my part, and thank you.
Hello everyone, my name is Karnananda son of Gunasekharan and I'm from class 2 BNF. My metric number is CN220005. Okay, I'm going to talk about the potential enhancement or the innovations for turbo code, especially for the security and privacy stuff. So there's a lot of potential enhancements. First of all, I'm going to talk about the cryptographic integrations. First potential, okay, it's the functions to improve the communication system security. Research can be done to combine turbo codes and cryptographic methods to secure the encoding and decoding process. This may entail use of cryptographic primitives. The second potential is key management. Provide effective turbo code key management systems. The security of the key used for encoding and decoding can have an impact on security and turbo codes. It is possible to investigate strong key exchange and management protocols. For third potential, it might be physical layer security. Examine the application of turbo codes to security and physical layer. This entails taking advantage of the physical communication channels properties to improve the security of data being transmitted. And the fourth one, maybe it's going to be stenography and watermarking. Examine the possibilities of turbo codes for watermarking and stenography applications. Turbo codes offer a safe way to encrypt data within communication signal, enabling an embedding of data in manner resistant to noise and interference. Okay, for the fifth one, the safe communication between multiple users. So create turbo code plans especially suited for the safe multi-user interactions. These may entail employing strategies to guarantee the privacy and security of the various users' messages in a multi-user communication setting. For 6 months, we're going to talk about the codes for quantum turbos. Okay, examine the application of turbo codes to quantum error correction methods. Turbo code can be adapted to the quantum domain for improved security as quantum communication systems uh, proliferate. Okay, security next potential will be the security through machine learning. Include machine learning methods in the turbo code framework for institution prevention and detection. Real-time security threat detection and response are possible with machine learning algorithms. For the final potential will be modifications of dynamic code. Examine method for improving security by dynamically altering the turbo code structure during the communication. Adapting code parameters to the perceived level of security threats can be one to achieve this. So that's all. Thank you.
Assalamualaikum. My name is Ilmah Faris bin Safrizal. Nama matric 3 DN 200001. Okay, I will present to you the advantage of the project. We have 7 points. First, we have excellent error correction performance. Turbo codes are known for the exceptional error correction performance. FSC is a theoretical maximum communication channel. Second, we have applicability to various communication standard. We have 1 point, which is several communication protocols such as satellite communication, deep space communication system, and 3D or 4G wireless communication. Okay, third we have iterative decoding improved performance. We have 1 point, which is turbo code error correction capabilities are improved by a iterative decoding process, which permit to repair a greater number of the error and non-iterative decoding method. Okay, fourth we have bandwidth efficiency. We have 1 point because of its reputation for achieving high bandwidth efficiency. Turbo codes are useful in communication system where spectrum alteration is essential. Okay. Next we have near Shannon limit performance. Turbo code have a great efficiency in using available communication channel resources, as seen by the performance that approach the Shannon limit. Next, we have robustness in a fading channel. It's because the turbo code function well in the fading channel. They are appropriate for wireless communication system which varying signal quality. Okay, last but not least, we have flexibility in code design. Turbo code provide a code design versatility by enabling customization for application and channel condition as well as adaptation to a various communication scenarios. Okay, next we have limitation of the project. We have 8 points. Okay, first we have complexity of implementation. Okay, first we have decoding algorithm for turbo codes can be computationally complex and need a significant amount of computer power. Application with stricken computing restrict can find a complexity to the hydrants. Okay, next we have delay introduction by irritative decoding. A certain amount of delay is the introduction by the irritative decoding process. And this delay might not be acceptable in the real-time communication system. Okay, third we have a sensitivity to channel characteristics. Okay, although turbo codes are effective in a variety of situations, their effectiveness may be susceptible to a certain feature of the communication channel. Okay, it's because requiring adjustment for diverse channel circumstances. Okay, next we have trade-off between performance and complexity. Turbo codes have a trade-off between computational complexity and performance, which affect their availability in the device application with limited resources. Okay, next we have finite blocks length effects. Impact of turbo code affecting their ability to recite error depending of the length of encoded data. Okay, next we have sensitivity to code parameters. The performance of turbo code is depend on parameter selections we made during the design stage. Therefore, getting the best result require considerable thought. Okay, next we have need to synchronization. A precise synchronization between the transmitter and receiver may be necessary for turbo codes, and the accurate synchronization may affect the decoding procedure. Last but not least, we have energy consumption. The amount of energy required for the decoding process in some application may be drawback, particularly for a battery operate of the energy constrained device. Okay, that's all for me. Thank you.
So, in conclusion, in a time of data-driven technology and linked digital ecosystems, security and privacy assurance are critical. So, the requirement for reliable and effective error correction approaches the preserve sensitive data confidentially while simultaneously ensuring information integrity is growing as the volume of SAM data increases. So recognized for their expertise in mistake correction, Turbo Codes have discovered another frontier in privacy and security. Thank you for lending your time.